now that we have a good idea of what functions are and their definition, we're going to move on to graphs of them. So within this, we're going to look at graphs, but incorporate our function notation, and they're going to give you things, and you have to interpret what it says, look at the graph, and grab the relevant information. So this is just extending our knowledge of these functions to graphs and kind of intersecting our knowledge of both of them. But also, for motivation, this is a giant part of the final that we do give you guys. Okay, so a lot of important stuff. Before we do that, though, I just want to take a minute or two and go back to this difference quotient. Okay, it's something that isn't going away. Yes, we use it in calculus, and this is getting you ready for it, but I understand not everyone is doing that. But it's still a process of, okay, you have an equation, I'm asking you to plug in different things within an equation and see what happens. Okay, so difference quotient is up here. I just picked some simple little quadratic. Now I think everybody could do something like f of 2. So you would go plug a 2 in, and you would see what happens, okay? You know, whatever it comes out to be. Okay, if I ask you to do f of a star, everybody could go, oh, I'm going to do 3 times a star squared minus 2 times a star plus 4, and then whatever it is. Okay, just pretend the stars are these things right here. This is what we're plugging in. And with the f of x, we're not really plugging in anything at all. Okay, so what our formula asks us to do is do f of x plus h. So everywhere we see an x, which is here and here, we're going to go plug that in. So if I want to do difference quotient, I'm going to say 3 times an x plus h quantity squared minus 2 times an x plus h. Don't forget about that 4. Now I'm going to subtract my function. That's all f of x is. So when I subtract, make sure we get a big bracket there because these signs are going to change. Okay, I'm not going to do anything with the h right now because that's just on the bottom. I'll go put that in at the very end. So now I just need to do some simplifying. So this is going to be 3. We'll use a little shortcut here. If you don't see where I got the shortcut, go right out an x plus h times an x plus h like that. Okay, distribute this negative all the way through so everything changes. Now, I got one more step because I got to simplify this. Okay, let's go look for some common terms. Those will cancel. Those will cancel. Those will cancel. And what am I left with? 6xh plus 3h squared minus 2h. All of this is over the h because all the terms have them. I can get rid of them, and what you get is 6x plus 3h minus 2. All that work to get 3 little terms down here. All right, back to some new stuff, graphs of functions. Okay, quick little reminders so we understand what we're trying to do here. Functions, each x gives you one y. Okay, we can do the little bubbles too. So you got some stuff over here in your input, you got some stuff over here. They have to just map to one place. You got your bubbles, and you have the same thing mapped 2 different places, not a function. Again, it's got to pass the vertical line test, so that's the visual test. We know domain is x values, we know range is y values. This notation, f parentheses x, okay, the value at x. So if you see something here, f of -2 equals 7, okay? So what it means, when you plug in a -2 for x, the equation gives you a value of 7. Think about a t-chart. You plug, whoops, that's not where the -2 would go. Here's x's, here's y. You plug in a -2, it gives you a 7. These are x's, this corresponds to the y. Remember the notation, y's and f of x's are really interchangeable. So as you can see here, if I say f of x equals 2x plus 1, it's the exact same thing as just saying y equals 2x plus 1. Everybody's comfortable with this. You'd start at 1 up 2 over 1. Notation, all it did was change to an f of x. Okay? The function changes as you plug x's into it. So x, y points are the same thing as x comma f of x points. So what do I mean? You could have x's and y's for this one right here. You plug a 0 in, you get a 1. You plug a 1 in, you get a 3. You plug a 2 in, you get a 5, and so on and so forth. We could write this as x f of x. That's this right here. You plug a 0 in for x, you get a 1. You plug a 1 in for x, you get a 3. Plug a 2 in, you get a 5, etc. They're the same thing. Okay? X comma y, x comma f of x. They're the exact same thing. All right, here's some new questions. So here's a graph. F of x equals x over an x plus 2. Make sure we're not doing this and just calling that 1/2. Okay, somewhere bad things are happening to pretty kittens. This, if it helps you, is the same thing as just a big y equals. So the first thing, is the point 1 comma 1/2 on the graph? So it's a yes/no question. Here's an x, here's a y. All we should have to do is go plug those in. Okay, so for this one right here, let's say 1/2. Does that equal 1 over a 1 plus 2? It does not. So that point is not on the graph. Okay, that was easy enough. Second question, if x equals a 2, what is f of x? So basically it's asking you for 2 comma question mark. If you plug in a 2, what do you get? Well, again, that's easy enough. Throw a 2 in, 2 plus 2, so 2 over 4 is 1/2. So the point 1 1/2 isn't on the graph, but the coordinate 2 1/2 is. If f of x equals 2, what is x? Now, what is x? So it's asking for something comma 2. If it gives you this, that's the same thing as telling you that the y value equals 2. Okay? They're asking for x, so they have to give you y. So if they're giving us that y value, we're going to go throw that in right up here. So we have 2 equals x over an x plus 2. We're going to have to take this blob and multiply both sides by it. So this comes out 2x plus 4. Obviously those will cancel. We're left with just an x here, and then everybody can say x equals -4. All right, if you want to check these in your calculator, we can do that, but we have to enter it correctly. Okay, let's go to the trusty calculator. Let's throw in an x divided by, make sure you get a parenthesis, or it's going to read it incorrectly, okay, because it's divided by the entire thing. Let's go to the table. And what were we asking for? If x equals -4, we should get a 2. That's exactly what we want. negative 4 and 2. Okay, if x equals 2, we should get 1/2, which is exactly what we're looking for. So we know we did that correctly. If you want to see a picture of what this looks like, you can graph it. Okay, there's going to be something happening at negative 2 because you can't throw in a negative 2 down there. Before we move on, let's make sure we fully answer everything here. We found what the x is, but it also asks what point is on the graph. So that would be negative 4, comma 2. So that's what we're looking for there. Okay, so once you find it, make sure we go back and plug it in so we get things that look like this. Okay, next, let's look at something more complicated. Okay, 3x squared all over an x plus 4. If you want to get an idea what it looks like, throw it in your calculator. It's the same kind of ideas here. So you might want to pause, copy down all these questions here, and then we'll go about solving them. So is the point x comma y on the graph? We're going to plug those in and see what happens. If x equals negative 6, what is the y value? What is f of x? It also asks for the point on the graph. And if f of x equals 2, what's the x? So they're basically this, remember, is your y value. So you're looking for the x value. What is the x? I'm actually going to pause it here. I'll meet you guys with the solutions. I would suggest doing the same. See if you agree with my answers. All right, here's what I got for some solutions. So first one I got yes, the math works out. For the second one, I plugged in a negative 6. This would be a really good time to discuss order of operations. So like this piece right here, it's not negative 18 squared. You have to do the exponents first, so it's 3 times 36. If you do that, you'll get negative 654. And the last one got a little tricky because when you plug that in for y and you solve across, you end up with a quadratic. So we set this equal to 0, building on stuff we've been doing for a long time now. I just did quadratic formula. Looks like it did factor, but I didn't want to sit there and play around with it. I got a 2, I got negative 4/3. So I actually got 2 different points for that. All right, you want to check these answers. Go to your trusty calculator, go to your y equals, make sure you divide it by the entire thing on the bottom. Now I went to the table set and I put this independent on ask. So that's when I come over here to the table, I can quickly look. So if I think negative 6 gives me negative 54, I know I did that right. And then my last 2 things over here, when I plug in a 2, I get a 2, and negative 4/3, I also get a 2. So one nice thing about this, you can check every single answer. Few more questions with the same problem. What's the domain? Well, we know domain is all the x values. Few ways we can look at it. We graph this guy. Okay, can't really tell there what happens, but we know zeros on the bottom are going to give us a hard time. So we can have anything we want for the x except a negative 4. We don't even care about what's on top right now, unless it's a square root. Okay, you have anything you want as long as it's not a negative 4. So if we go to our table, if we plug in negative 4, error, so we know we did that right. Okay, list the x-intercepts, if any, of the graph. If we look at it, it looks like it's going to hit the x-axis somewhere. What do we know about an x-intercept? We know it's x-intercept, comma, 0. So we know that the y value is nothing. We just have to go ahead and solve this. Now, what happens when I multiply across by an x plus 4 and another x plus 4. Zeros are really nice because that side's going to stay at 0. Okay, we divide by 3. We get x squared equals 0. So the x-intercept is 0, 0, right at the origin. There's not a plus or minus 0. There can only be one of them. Last piece, listing y-intercepts. So what do we know about y-intercepts? Well, the x value is 0, and then it's got the y-intercept. So this one should be pretty easy too. We're going to go plug in f of 0 and see what we get. So everywhere we see an x, throw a 0 in. X and y-intercept are the same thing, right at 0, 0. Next piece, what if you have something, it's a nice smooth curve and it gives you a bunch of points? Yeah, so it's pretty much the same idea. It's going to be the same questions here. We just have to look at it a little bit differently. So I just grabbed this one off Interact Math. Again, I would recommend pausing it and copying down those questions, maybe even give them a shot and see what we come up with. So first one, what's f of 0? What's f of 4? What's f of 27? Just remember, this is really like f of x. Okay, so these are x values. So we're saying, what is the value of the function when you plug in a 0? So we're going to look at all our x values, which we know are down here, and see what happens. When we plug in a 0, we get right there. So f of 0 is 6. F of 4. When you go to 4, what's the graph give you? The graph hits 8. When you go to 27, 22, we don't have anything. Okay, so we can kind of say a lot of different things. We could say, we don't know, not valid, inconclusive. I'm just going to say not applicable. We have no idea. The graph stops at 22. We can't say it's 0. This is something that has a 0. This has a 0, but we don't know what happens at 27. Domain. Domain is our x values. Where can the graph start? Where does the graph finish? Well, it looks like we start at negative 12 and we go all the way up to 22. So if we put that in interval notation, we're going negative 12 up to 22. We're looking at x values. What's the range? We're looking at y values. So find the lowest place the graph goes, find the highest place the graph goes. The lowest this graph ever hits is negative 6. The highest this graph hits is 8. Put it in interval notation. We're going from negative 6 up to 8. List all intercepts. This should be pretty easy as long as they're nice, clean, whole numbers. There's one of them. There's another one. Here's your third one. Actually, we missed one on the x. So there's 3 x-intercepts, and there's 1 y-intercept. Negative 6, 0, 12, 0, and the last one is 20, 0. Y-intercepts, 0, 6. Right. Same picture, some more questions. Again, I would pause it and get those copied down. How often does the line y equals 2 intersect this graph? Think about what that is. The line y equals 2, it's a horizontal line going right through 2. It doesn't say where, it just says how often. Three times. For what values of x does f of x equal negative 4? Now, this is where you have to interpret what it's really asking. Again, it's asking for values of x, and it's saying f of x equals -4. So it's basically telling you the y value is -4. You're trying to fill in this first number right here. So go every place that the y value is -4 and tell me what that is. For what values of x does f of x equal -4? So we're going to say at -10, and we're going to say 16. We should probably write these as points. Because if you say x equals -10, technically it's an up and down line. So we'll just go with the whole points there. Last question. For what values of x is f of x greater than 0? Again, we're asking for x, but you have to interpret what this is saying. So basically, where is the function positive? You don't like the word graph, or I'm sorry, if you don't like the word function, think about where's the graph positive? That's all it's really asking. Where is it above 0? Well, it's above 0 here, and it's above 0 here. Okay, but we want the x values, not the y values. So we want from here to here, which is going to get us from -6 to 20. Now I erased that bracket because I remembered that this is greater than 0, not greater than or equal to. So I'm going to say from -6 to 20 in interval notation. And then also from 20 to 22 in interval notation. Now we could also ask where's the graph negative, and you could give me those corresponding points as well. Okay, but it's not a greater than or equal to, so just after -6 the graph's bigger than 0. But at -6 it's exactly 0. All right, we've been giving you guys a few questions kind of at the end of the lessons. We're actually going to change that a little bit and use the Google Docs thing. So if you're watching this on your laptop, it should actually be a little bit quicker, and we can record responses as well because your username will show up with it. So if you go back to the blog for me, there'll be a link underneath. It'll take you to a Google form. It's 3 quick little questions. I want you guys to try those out tonight. If for some reason it's not working, because it's the first time we've done it, here's the 3 questions. But I do want you guys to submit these through the Google Forms just so we can kind of see what's going on with it. This second question here should look like that. So we're trying to find an A value for that. And just get that down to another line. All right, so get those responses filled out. It was a lot of stuff today, so we're going to hammer this in class tomorrow, and we'll see you guys then.